This is the brief on the power of dimensional analysis in simplifying physics toward universal laws. So, what is dimensional analysis? Well, it basically uses fundamental units, like mass, length, and time, to simplify really complex physics problems. It acts as this incredible engine that makes engineering and experimentation radically more efficient. All right, so how does it do this? We've got three key takeaways. First, dimensional analysis is an amazing complexity filter because it drastically reduces the number of variables you need. Using the Buckingham Pi theorem, you can take something super intense like heat transport with 5 messy physical parameters and boil it all down to just 2 simple universal variables. This gives engineers a single, manageable blueprint instead of an infinite number of solutions. Second, it guarantees dimensional consistency. And that's just a fancy way of saying that the fundamental rules of the universe don't change just because you change how you measure things. It doesn't matter if you're using newtons or pounds, the math always has to balance. This confirms your calculations are describing something real and reliable. And finally, while it's fantastic at predicting the form of physical laws, like knowing a spring's period is proportional to the square root of mass, it does have one critical limitation. It can't determine the dimensionless constant, that pure number, like a 2 pi, that turns a proportionality into a full equation. For that, you still need to do the experiments. So really, dimensional analysis is the essential framework for transforming specific, complex observations into powerful, universal scientific laws.